Okay, so this is the second problem we are solving um, for the course of Principles of Physics. And this one also involves vector. And we are supposed to use vector to solve this problem. So let's see how vectors might come up in the context of this problem. So first it says the raindrops are falling at a speed of 6 meters per second. So it means it's raining. So raindrops are falling, presumably in the same direction, and which is vertically downward. And it says you were also running at a speed of 6 meters per second. So I'm presuming that you're moving in the horizontal direction. So this is the direction. And your speed is 6 meters per second, which is the same as that of the raindrops, which is falling downward with the same speed. Now the question is, at which direction you should hold your umbrella in order to remain dry? So that's an interesting question, and there is a concept that you can familiarize yourself to, or that I can introduce you to, and that is the concept of relative velocity. Relative velocity. So before I solve this problem, I want to clarify this concept. What is relative velocity? So for example, you and your friend, both of you are moving in the same direction. So let's say you are running and competing against each other. And let's say for some reason you get ahead of your friend. And so that means your speed, in this case your velocity, is greater than that of your friends. That's what it means to get ahead. So that means your speed is greater, your friend's speed is less than your speed. So since you're moving in the same direction, that's why I can use the word speed. But in this case, they are interchangeable because there's just one direction involved with this problem. So now, if your velocity is Vy, so this is your velocity, and if your friend's velocity is Vf, then the relative velocity of your friend is given by Vr, where R stands for relative, equals your friend's velocity minus your velocity. This is important. So if you're finding the relative velocity of your friend, then you subtract your velocity with respect to your friend's velocity. And that will give you your friend's relative velocity with respect to you. So if you want to understand the concept more concretely, so for example, your friend is moving at 4 meters per second, and you are moving at a speed of 5 meters per second. So your friend's relative velocity Vr, right, which in this case, since it's a one-dimensional motion, is going to be Vf, which is 4 meters per second, minus your velocity, which is 5 meters per second, and this is going to give us negative 1 meter per second. But since you're going ahead, from your frame of reference, you'll see that your friend is getting more and more behind, is actually going in the backward direction because you are moving faster and you are getting ahead. how will your friend view you? So your relative velocity, so let me denote it by v prime. Your relative velocity with respect to your friend will be your velocity minus your friend's velocity. So in this case, Vr is going to be Vy minus Vf, which is numerically given by 5 meter per second minus 4 meter per second. And that is 1 meter per second. So your friend will observe that you, in his reference frame, is getting ahead with the speed of 1 meter per second. That's what your relative velocity is with respect to him. Now, we all know we ourselves are stationary with respect to our own. So that is very clear from this formula. So your relative velocity, I should give here a prime, and your relative velocity with respect to you, so as denoted by Vr double prime, equals Vy minus Vy, which is 0 meter per second. It's because we all are stationary in our own reference frame. I hope this clarifies this discussion. This is really a simple concept, yet very powerful, and this is the concept we are going to employ in this particular problem we just have had. So the problem is much easier if we set up a coordinate system. So we are assuming that you are moving along the x coordinate, so this is x, right? And the rain is falling in the negative y direction, so this is y, and this is the direction of rain, and this is your motion, right? And so this is u, and the umbrella should be held in a direction which opposes the direction of rain. So this is basically asking that what should be the relative velocity of rain be so that your umbrella should direct in the opposite direction of the rain. So according to the concept of relative velocity that we have just learned, this should be calculated as follows. So what do we have? We have the relative velocity of rain, right, equals the relative velocity of rain is given by the actual velocity of the rain. And since you want to find out the relative velocity with respect to you, I mean the velocity of rain relative to you, so you'll have to subtract your own velocity. So this is what we are looking for. We are actually looking for the negative of this thing, all right? So what does that mean? It means that you need to find out the negative of your velocity, and then the relative velocity of rain points in this direction, and your umbrella should be held in that direction. All right? So in this coordinate, the velocity of rain, what it should be negative 6 meter per second in the y direction. Remember, this negative sign is because the rain is falling in the negative y direction. So this minus sign negative sign is directing the direction of the raindrops. Minus, this minus is because of the minus we have here, right? This minus here. And then your velocity in the positive x direction, so it has to be 6 meters per second and then x hat. Okay, so this is the relative velocity of the rain. Now we have to find out the direction. That means we'll have to find out the unit vector, and as you can calculate, the magnitude of VR is simply square root -6 whole squared plus -6 whole squared, and then we have meter per second. You have to remember the units, and this is simply going to be 6√2 meter per second. Okay, so the direction along which we have to hold the umbrella is, let it be n hat, and n hat is -v r divided by VR, and this is going to be 1/√2 x hat plus 1/√2 y hat, and this is the direction along which your umbrella should be held in order not to get wet.